In today's video, we'll look at two final related rate examples. These ones come from section 3.9 in your textbook. So we have a man starts walking north at 4 feet per second from a point P. So we'll say that this is point P here, and the man is walking north. 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 due east of P. So that means this must be 500, and she's walking due south. So this is our man, and this is our woman. At what rate are the people moving apart? 15 minutes after the woman starts walking. Okay, so keep in mind it's 15 minutes after the woman starts walking, meaning that it will be 20 minutes after the man starts walking because the woman started 15 minutes or 5 minutes afterwards. So what we're really looking to find is the rate of this distance here. Okay, the distance between the man and the woman's position, how that rate is changing. What we'll do is we'll turn that into a right triangle. And I'll just redraw that over here. This distance we know is 500. It's constant, so we can put it in right away. Our vertical height there, well, that's the man's distance plus the woman's distance. So we'll call that m plus w. And then the other distance we don't know. So maybe we'll call that x. So the relationship that we know we're working with here is that 500 squared plus m plus w squared should equal x squared. 500 was a constant, which is why we could put that in directly. So we'll go ahead and we'll take our derivative. Derivative of 500 squared, that's a constant, so that's just 0. Derivative of the m plus w squared, we'll get 2 to the first times dm dt plus dw dt. And that's going to be equal to 2x dx dt. Now the thing we're looking for is the rate that the man and the woman are moving apart, so that's really dx dt that we're trying to find. That means that we should be able to find everything else other than dx dt. So let's start out, we'll have 2. Now for the lengths m and w, we're going to have to do a little work. They gave us the man and the woman's rates in feet per second, and notice we had minutes. So let's start with the man. We'll start down here. The man was walking for 20 minutes because we want to find 15 minutes after the woman started walking, so that means the man was going for 20 minutes. They were going 4 feet per second. Well, we don't want feet per second. We want feet per minute because we're in minutes, so we need to do times 60. So this is minutes. This is feet per second. And this is that there's 60 seconds in 1 minute. So again, 60 seconds in 1 minute. So just so you can see how the units work out, so the seconds will cancel out, the minutes will cancel out, and this will leave us with a feet amount. When we multiply those all together, we get 4,800 feet. And again, we had to do that conversion because the rate was in seconds, and we were working with minutes. Now the woman, we were going 15 minutes after she started, had a rate of 5 feet per second. and then we'll multiply that by 60 seconds in 1 minute. Again, the seconds will cancel out, the minutes will cancel out, so we'll again have a feet amount. Her feet traveled is 4,500 feet. So we'll go back to our derivative now. We had 2 times m plus w to the first. Well, we just found m was 4,800, and we found w was 4,500. So together, that gives us 9,300. Times we've got our rate for our man was 4, plus our rate for our woman was 5. Then we've got equals 2 times whatever x is times dx dt. Well, to find x, we're going to have to do Pythagorean theorem. We'll do that off to the side. We know that this base was 500. We found that the height here was 9,300, and we're finding x. So we'll do 500 squared plus 9,300 squared equals x squared. And eventually we'll get x is equal to the square root of 8,674 and then 4 zeros. So it looks like we'll need some more room for that. So this will be equal to 2 times the square root of 8,674 and then 4 zeros dx dt. And then all we need to do is get dx dt by itself. When you do that, you'll get approximately 8.99. Since we put our rates in as 4 and 5, that was in feet per second, so this rate must also be feet per second. If you kept it in an exact form, this would be 167,400 over the 2 square root of 8,674,000. And that could simplify some. You could take a 2 out, but that's what it could be if you wanted it in exact form. One last related rate example. This is from number 20 in section 3.9 from your book. A boat is pulled into a dock by a rope attached to the bow of the boat and passing through a pulley on the dock that is 1 meter higher than the bow of the boat. So in other words, we know this is going to be 1 meter. If the rope is pulled at a rate of 1 meter per second, how fast is the boat approaching the dock when it is 8 meters from the dock? So we're going to have a right triangle set up. That height is always constant at 1. And we don't know these two distances. Let's call them x and y. The thing we're looking to find is the rate that the boat is approaching the dock. So we want to know dx dt. Meaning once we take the derivative, we should be able to sub in for everything except for dx dt. So we'll have x squared plus 1 squared equals y squared. That's 2x dx dt. 1 squared is 1, and the derivative of that is just 0. So then we'll have 2y dy dt. Well, we'll have 2. We want to know when the boat is 8 meters from the dock, so x will be 8. We'll have dx dt. We'll have 2. Now we've got to figure out what y will equal at that instant. This was always 1. We're finding at the instant this is 8. To find y, we'll have that y squared is equal to 8 squared plus 1 squared. So y will end up equaling the square root of 65. And the rope was moving at 1 meter per second. Now, that distance was getting smaller, so we need to put it in as a -1. And if we now solve for dx dt, we'll have 16 dx dt equals -2 square root of 65. Divide the 16 over, we'll have dx dt is equal to negative square root of 65 over 8. And if you were to punch that in your calculator, that's about -1.01. Now our units, our distance unit was meters, our time unit was seconds, so each of these would be in meters per second. That's all for today's video. We'll see you next class period.